The rocks that compose the spectacular mountain scenery of the Teton Range were mapped by U.S. Geological Survey geologist Dr. John C. Reed, Jr. between 1962 and 1970. In this video recording, made at Inspiration Point above Jenny Lake in July 2013, Dr. Reed describes the day-to-day work of the field geologist.
And we've walked part way up the trail from Jenny Lake toward the Inspiration Point. And this is the place where we can actually sit on the rocks that form the uplifted block, the block that is west of Jackson Hole. The rock I'm sitting on is a fine-grained granite, and you can see some white irregular areas, and those are pegmatites. They are made of exactly the same minerals as granite, but they have formed by slow crystallization at the end of the granite crystallization. And we now know that these rocks are very close to 2.5 billion years old. Now the magma, molten rock, which formed the granite, was injected into older rocks, which are mainly gneisses and schists, metamorphic rocks of various types, and there's a great variety of them, and I'm not going to bore you with them. You may wonder how we go about mapping and understanding these rocks. Well, the answer is you walk uphill a lot. And what we do is wander up the outcrops, the ridges, and the canyons, and we carefully examine the rocks, identify them. This is granite. And then we also make observations of the direction and slope of the various planes in the rock. We would measure in sedimentary rocks the orientation of the beds. In these rocks, we would measure the orientation and slope of various structures that were produced under the intense metamorphism. And to do that, we use this little gadget called a Brunton compass. We can very accurately, let me take this plane right here, the flat surface. This happens to be a joint plane. And what I usually do is lay a stiff notebook on that just so I have something flat. There is only one set of lines that are horizontal, and they run this way. And that is called the strike of the plane. And then, and I measure that by looking down and looking at my compass and writing down the direction. And I do that usually to about the nearest 5 degrees. And then I take my compass and I put it this way, and I've got a little level on it that lets me measure the angle from horizontal, and that is called the dip. And we take strikes and dips literally by the hundreds and even by the thousands. And then while we're doing this, we take our field book and we write all this information down, and we put a place on the map where we took that observation. And so this notebook contains probably several months' work, right? At the same time we're doing all this, we're collecting samples of the rock. Now, unfortunately, we've forgot our official geologic pick, And this is what you might say is a geochronologist's hammer. So we collect samples by breaking off pieces of the outcrop to the dismay of the National Park Service. We take them back and we study them under the microscope to identify the minerals and identify the textures. Some of them we analyze chemically, and some of them we use to date by geochronology. And all of this is what we do in the winter between field seasons.